So we can move on to the next talk. That's the third presentation. The final presentation is titled Fair Data and SEAGrid Gateway, a Research Data Alliance Adoption Project. And the presenter is Rob Quick.
Hello. And let me share my screen here. Share and view. Let's see, and let me know if you're seeing my screen correctly.
Yeah, we can see it.
Okay, great. So somewhat inspired by the plenary talk this morning, I'm going to start off with a statement here that I hope can lure everybody in. I think it's a statement that actually everybody will agree to, but it's easy to get lost in a conference like this where we're talking about gateways. But the statement I want to make is that the research enabled by a gateway is much more important than the gateway itself. Right, so we all have got jobs that relate to gateways, so it's hard to think about that, but I think it's important to realize that the research, the gateway is a tool to accomplish the research, and the research is really the goal here, and research that allows some decision making or some advancement in wisdom. So I wanted to start with that statement because I think the gateways themselves are somewhat transient. They come, they go. The research, though, should be permanent. And one way to think about that is by saying that we want the data and, in fact, even the workflows to move towards the FAIR principles. And at this point, everybody's probably heard FAIR so many times that they're tired of it, and they know what the acronym means. They know findable, accessible, interoperable, reusable, like the back of their hand. Though they may not have put much thought into what those words mean beyond that, and we'll talk a little bit about that. And in fact, the project that we got funded by the Research Data Alliance to do was to look at a specific gateway, in this case, the SEAGrid gateway, the Science Engineering Application Grid Gateway, and a data infrastructure called RAPID, which is the robust persistent identification of data. And I'll talk more about both of those a little bit going forward. But to see if we could take what are the core FAIR principles, at least the technical portions of the FAIR principles, not so much the social portions, and apply them to a gateway environment and what that really looks like. So to set some possible scenarios, as I said, these gateways are tools for researchers. The researcher may be concerned that the digital objects they use or produce are governed by FAIR principles. They may have heard the buzzwords, they may have put it in their proposal, they may have agreed with what the word's meaning was, though didn't think so much about how to actually enable fairness. They may want their research to be reproducible outside of the science gateway environment. As I said, the gateways themselves are tools that will come and go over time. And I don't think we should expect that the gateway will be a permanent place that the research will live. Obviously, the data lives outside of it. The publications live outside of that. And in fact, you want your research to be reproducible, even if the Science Gateway is unavailable or possibly retired at that point after some number of years or some amount of effort. They may want to share the steps or the workflow, not just the results. So yeah, they may want to have some record of the workflow, again, outside of the gateway to share with collaborators or to put in a publication. And they may want to reuse that workflow with some amount of tweaks. Say a new version of software comes out. I just want to drop in a new version of software. I don't want to have to point all of my new data at it, or all of the intermediate steps, just drop in a new piece of software. So those are some scenarios. But first, a reminder of what the FAIR principles are. Again, everybody knows the words, but I don't know that so many people have read exactly what FAIR means. And FAIR means several things. And this slide, produced by Luis Benino, shows the difference between the green is what can be implemented on a technical side or through software, whereas the black or blue, whatever you may be seeing, text is more of what is a social contract, right? So looking at F1, you can technically assign a globally unique identifier, but there's some social contract in saying that the systems that record that identifier will be persistent. The same thing with F2, data can be described with rich metadata, and you can make a mechanism to do that. However, the rich portion of that is up to the social contract and the researcher to, or the community to implement. The other ones here, and again, we centered on the green things, the things that were technically implementable. And I don't want to go through all of this because this is a relatively short presentation, but we focused on those things in RAPID. RAPID, the robust persistent identification of data, is basically a handle service or a PID issuing service, and that holds the metadata, resolves to the global system, the same global system that is used for DOIs, and many of the other data site uses it also. So I'm going to move in. SEAGrid here is basically a relatively general grid for science and engineering applications. It's built on Apache Ariavada. And the adoption that we did here was centered on small molecules and their fluorescent properties. I will show a bit of that if I have time here, because I want to show you how you take what you've done in a gateway and actually find out information about it externally. So the Rapid Testbed is a data cyber infrastructure. It's something I've been funded by the NSF to work on. It is entering year 3 right now, but basically it has the cyber infrastructure for minting PIDs, resolving them to get metadata, a data type registry, so you know the meaning of that data and what type it's actually in, and then a protocol. In this case, it's called the Digital Object Interface Protocol that allows operations on digital objects. And it's basically the cyber infrastructure that it's a cyber infrastructure. It's not the only cyber infrastructure that does it, but can implement those technical components of the FAIR principles that we looked at a few slides ago. And it leverages several things from RDA and then some existing software, including a persistent identifier kernel information strawman profile, basically a profile of the metadata and the data types, a data type registry. And then it does, the group within RDA called the Data Fabric Working Group theorized a bunch of this. We took it to the NSF, got funded to work on it. And there's more for this at the link here below. And here's the idea of using PIDs. PIDs are cheap, inexpensive, easy to issue. And so what if we assigned PIDs on every step of the workflow? So the raw data, either in the file or the raw data file are in other formats, can be assigned a PID for each piece of that. Any preparation software or pre-preparation can be given a PID. The same with intermediate data products, the final analysis application of software, and the final data products. They all get persistent identifiers that are resolvable with metadata about the workflow steps. So the simple example of the phosphorescent molecules, or the fluorescent molecules, sorry, that I mentioned earlier, is shown in this tree. It's really, this is a very simple, but basically the workflow itself is given a PID. So when you hit submit a job, it's given a PID for for a group of other pieces of metadata. It's split into input, software, and output PIDs. And these have various different things. The input has the actual molecule, in this case, the coordinates of each of the atoms in the molecule, the charges on those. It also has some of the things that are used in input for the, in this case, Gaussian software. The software PID has the name, the version, and other bits and pieces. In fact, the software should probably be split into a software and environmental PID because some of the things we captured in the software PID are more environmental type variables. And then the output ID has the error, the output, and the log information. So these could all be assigned to PID. These are all retrievable externally. So if 2 months later I want to go back and see what version I'm writing the paper 2 months after I did the initial run, I want to know what the exact version of the PID, or I'm sorry, the exact version of the software I used. I can do that. And I will show that here real quickly. I have this set up. Whoops. So this is the area Vada, and let me get it on a bigger view here. The workflow, you can see this is a workflow I ran a few months ago. Again, I'm writing a paper today. I have a, for example, if this gateway is gone, I still can get this PID. I have this PID, I take it to the handle.net, which is the global resolution system. It sends me back to the rapid services. Here you can see that I have PIDs that are the input data, the output data, and the software data. In this case, I'm looking for the version of the Gaussian software as I write the paper to make sure that it's not or that it's correct when I publish this. I can follow this PID down here to find the app module version. I can grab this from right here. Again, I don't need any access to the gateway to do this. And I found my version. I can put that in my paper. If I want to change that version in the workflow, I can put in a PID that is, a new version or a different version or something along those lines. And I think I'm running out of time, so I will get to my conclusions here as soon as I can exit full screen mode and get back to my presentation. Okay, so we did this integration. SEAGrid is working with this. It's available at rapid.seagrid.org if anybody wants to play with it. And it implements the issuing of PIDs, the gathering of metadata that is resolvable externally, and it does use actually the digital object interface protocol that I talked about. And these describe basically the workflow components. You can use this to recreate the entire computational workflow without having any access to the gateway. So if a researcher picks up your paper and says, I want to recreate this workflow, but I don't want to do it in the gateway environment, they can do that by getting all of the metadata information about the workflow that was used within the gateway. Again, this well, not again, but this directly impacts the mostly the FA and I parts of FAIR. So the FA, the R has much more to do with the reusable with the social contracts and the metadata that is required to be gathered. So it's much more of a discipline or a community enforcing that to make those reusable. Nicely, this is extendable to other area Vada-based gateways pretty easily. In fact, we have a client, so it could be moved to any gateway, not necessarily just area Vada-based science gateways. And it leverages the RDA community, and in fact, was funded by the RDA. So we have some future work, document the client deployment. There is documentation, it needs to be tested and maybe reworked to be more user-friendly. We did this on a very simple workflow. We'll have to do more complex workflows. So something like the common workflow language may need to be integrated. I showed it in the tree structure. It's probably more of a DAG structure, a directed acyclic graph type structure of what workflows really work in. We wouldn't want people to have to copy and paste through various different things like I showed through various different web pages to get the information. So it needs some sort of workflow visualization that is representable in something a researcher could read quickly without having to copy and paste many PIDs to get the information. We're looking at the possibility of then using the data to populate public repositories. In this case, the floraforbes.org, because this was fluorescent materials. And the other ones, Rapid itself right now is in a Testbed service. It was funded in the Eager Award, so it would have to operationalize to be used in general. It's a very stable and very robust service running on Jetstream right now, but it would need some operational components. And then we have some testing that's been done on the performance of how many PIDs can be both resolved and issued, and they're in the hundreds per second. However, that comes from the developer of that service, so we would want to do some independent performance analysis before we release this widely into the community. And with that, I will see if I can escape and stop sharing and take questions. Hopefully, Suba, that was in a reasonable time.
I think so. I I just went 1 minute over. That's fine. So thank you, Rob. And any questions for Rob? And I see one in chat. Let me quickly see. So the question is, have you implemented this on any non-Apache Airavata gateway to date?
So no, to date, we were only funded to do this on the one gateway. It was a small, short award, ran from January to June of this year. It funded about 20% of a person. So this is the only implementation we've done. However, the client is independent of Apache Airavata and can be picked up from GitHub, reused. Again, the instructions probably need to be gone through, but we would love someone to test it and see if the instructions were reusable outside of the people who have developed it. But there's no reason that it can't be done. It just hasn't yet.
Any other questions for Rob? Maybe I can ask one. So what was the level of effort that was needed to change, to incorporate this into SEAGrid? Because SEAGrid was an existing gateway, right? So what is it? Maybe you can give us an idea of the effort involved.
So I can give you so for those 6 months, it funded approximately 0.2 FTE. However, that was the initial interaction, and I don't think that it would take that long again, because now we have the client again independent. However, doing it the first time takes some amount of effort and some integration, and I would see that future it should not take nearly that much. If it takes that much, then obviously we don't have a product that can be reused widely.